So, after average velocity, we are going to talk on instantaneous velocity. So, instantaneous velocity is the velocity at a particular instant of time. So, O is the instantaneous rate of change of A of position. O, the most precise one, is the limit of average velocity as time approaches 0. Now, remember that average velocity V, average velocity bar, is equivalent to what we say delta x over delta t. While instantaneous velocity Vx, it says is the limit of average velocity, meaning VAV at t approaches 0. Meaning, from here we can say that Vx equals to lim at t approaches 0 into since BA here is the delta x or delta t, delta x over delta t. So either you use this or it's all the same. So now, since we are talking about limit, that is tangent, and say that Vx is going to add to say dx all over dt. So either we use this or use this. They all belong to instantaneous velocity. So then we are talking about the next one is acceleration. So we say there are some physical things that are used to describe motion. The lack of speed and velocity, distance and displacement. Now I think about acceleration. Next one is what is acceleration. Acceleration. Acceleration, as we know, is the rate of change of velocity. The rate of change of velocity is the rate of change of velocity. Meaning, mathematically, acceleration A is equal to velocity all over time. This means that acceleration is also a vector quantity and has a unit of meter Pascal square as the unit of acceleration. So then average acceleration, A average, in this case is the in this case is the change in is delta V over delta t, which is equivalent to V2 minus V1 over T2 minus T1. But we normally use U, V, and U to describe initial and final velocity. Remember that initial velocity U is known as initial velocity. That is velocity at the start or at the beginning of the motion. Normally, when body is at rest, remember that a body at rest has what? Initial velocity of 0. Because the body is at rest, meaning the body does not start to what? To move. Meaning it has a 0 what? Initial velocity. The initial velocity is 0. Then we have the V, which is what called the final what? Velocity. So from here, because here we have final V and initial U over what? T2 minus what? T1. So, and also we have something that we call instantaneous acceleration. Instantaneous acceleration, AX. Here, we say is the limit of what? Of average rate acceleration. That is delta V over what? Delta T at T approaches what? 0. This means that from here, according to the tangent, AX is equal to what? dx, no dv, over what? Over dt. As tangent A. So please remember that again, that acceleration is velocity over time, average velocity, final velocity initial all over t2 minus t1, then instantaneous acceleration AX. Here we call it what? The instantaneous acceleration. So remember that problems related to linear motion are solved usually using some expression or equations. So we call this equation equation of linear accelerated motions. Equation of what? Equation of what? Linear motion. The first one, we have V equals to U plus what? AT. What is absent in this equation is S. S is what? S is absent. Meaning distance slope is absent, or X. Let's use S. The second one, we have V square equals to U square plus 2AX. Let me use X here. Distance is absent. In this case, time is missing. Then we have another one here. We have X equals to UT plus what? AT square all over 2. In this case, we all know that V is missing. If we have average distance, it is known as X equals to V minus U all over 2 times time. In this case, acceleration is what is missing. So, if we can master this, all these short equations, these are the problems that are related to linear motion are solved within all these form of what? All these equations. So now I am going to summarize all the formulas here in this case so that we can use all these equations, one formula equation, to solve questions or problems related to what? To linear motion. And also, please be advised that instantaneous velocity and instantaneous acceleration are solved using what? Using differential equation. Now, for example, in terms of velocity, Vx, instantaneous velocity, we say that it says, for example, now If, for example, now we have something v, for example, or x power n here is equivalent to what? We say here n x n minus 1, meaning we multiply the power, or the index, we multiply by the x, then we reduce the power by 1. Whenever you come across a constant without x, constant, just a number, a constant, make it to be what? To be 0. So I have forgotten to say that this instantaneous acceleration is the second derivative of instantaneous velocity. If Vx is dx over dt, then ax here in this case is something as what? D square v over what? dt square. But we are doing it in terms of x. Here we said ax equals to what? Is equivalent to d square x over what? dt square. So now be advised, this is what we are going to use to solve any equation related to instantaneous acceleration or instantaneous velocity. Whenever you find an x to the power of n, remember you multiply the x by n by the power, then you do the power by 1. When you see a constant without a number, just constant means a number or any alphabet which is not a variable, you have to equate it to 0. So, and also velocity, for instantaneous velocity, we differentiate it once, we differentiate x only one time. While for instantaneous acceleration, we differentiate it x meaning 2 times, meaning we are going to use this 2 times, unless if velocity is given. So now I'm going to use some question to apply all these kind of rules in solving what? Instantaneous acceleration and also instantaneous velocity. Now I'm going to summarize these formulas on one side so that I can read the other side in solving what? The question.